Let us start with question number 33. That is, we have to check the convergence of series 1 upon n raised to the n. So, if we apply root test, that is, if L is equal to limit of xn raised to the 1 by n, here xn is our 1 upon n raised to the n. So, limit is L is equal to limit of 1 upon n raised to the n raised to the 1 by n. So this is limit of 1 raised to the 1 by n upon n raised to the n raised to the 1 by n. So this is equal to limit of 1 upon n, as a limit n tending to infinity, this is 1 upon infinity, so this is 0, which is less than 1. We know that in root test, if limit is less than 1, then our series is convergent series. So this is convergent series. Next question, that is question number 34. In question number 34, we have to check the convergence of this series for x is greater than 0. So we can apply root test here. L is equal to limit of, that is in infinite series, if we are taking the limit, then this limit is always n tending to infinity. So if L is equal to limit n tending to infinity n raised to the x raised to the n upon n raised to the n raised to the 1 by n. So this becomes limit n tending to infinity x by n. For all x, this limit tends to 0, because if we substitute the value of n, then this becomes x by infinity, so it tending to 0. So this limit is 0, and this limit is less than 1. Therefore, by root test, given series is convergent. So given series is convergent series. Next question is, that is question number 35. In question number 35, it is given that series is in the form of 1 by 2 plus 3 by 4 plus 4 by 9 plus dash 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 plus n plus 1 upon n cube. Here nth term we can say un, or you can we can say it as xn or yn, it doesn't matter. So here nth term is n plus 1 upon n cube. So it is in the form of polynomial upon polynomial type. We know that there is one test to check convergence of such a series. If xn and yn are two positive term series, and if L is equal to limit of xn upon yn, if this is finite and non-zero, then xn and yn behaves alike, that is, both series converge together or diverge together. Here we have to choose the series yn. So generally we are choosing series yn as n raised to the p upon n raised to the q, where p is highest power of n in a numerator of a series xn, and q is highest power of n in denominator of a series xn. So in this way we are choosing series yn. As a given series is un, we can take another series vn. This is equal to n raised to the p upon n raised to the q. Here p is highest power of n in numerator, that is n raised to the 1, in denominator it is n cube, so it becomes 1 upon n square. So this is series vn. So nth term of series is this 1 by n square. If we take L is equal to limit of un upon vn, so this is equal to limit of un is n plus 1 upon n cube upon 1 by n square. So this can be written as limit of n plus 1 upon n cube into n square. So this is n square, and n square get cancelled, so only remaining part is limit of n plus 1 by n. So this limit is limit of 1 plus 1 by n, so this limit is 1. Here limit is finite and non-zero. Limit is finite and non-zero. Therefore both series converge or diverge together, but we know that this is a p series and this p is greater than 1, Therefore Vn is convergent. This implies our series Un is also convergent. Therefore given series, that is Un, is equal to n plus 1 upon n cube, that is this series